So we're going to look at what are generally called the special ratios or the special triangles. And these are angles where we can actually find a nice algebraic set of ratios for sine, cos, and tan for these angles. And so what I mean by algebraic is we don't have to like round them to a four-digit decimal number. We can actually write them out as their exact values and in a fairly nice way. So the first one is going to be pi over 4. So let's say theta is pi over 4. I usually like to work with decimals in my head. I don't have a clear idea of what a pi angle looks like, so I'm going to convert that. If you remember, pi is 180 degrees. And so 180 over 4 is actually 45 degrees. So this makes a nice special angle. I'm going to draw my right angle triangle with a 45-degree angle. That looks not perfect, but good enough. That doesn't even look like a right angle, but hopefully you get the idea here. Ooh. Yeah, so we'll have our right angle, 45 degrees. So if this first angle is 45, we can use the property of the triangle to get that the second angle is also 45, right? All of the angles should add up to 180 degrees. So both will be 45. And what that actually tells us is that we have an isosceles triangle. So those two sides are the exact same. There's symmetry with this triangle. And that's going to actually allow us to come up with the trig ratios. I don't need any sides specifically. What I can do though is just make up sides. It doesn't really matter because it's all going to be ratios. So if this side here has a length of 1, then by symmetry, this side down here will also have a length of 1. And then if we use the Pythagorean theorem, I would have hypotenuse squared is 1 squared plus 1 squared is 2. And that should tell me that the other side is going to be the square root of 2. You could have done this with any other set of sides. Like I could have chosen, let's say 4 and 4. And then 4 squared plus 4 squared is 32. So I would have like root 32, which is 4 root 2. If you remember how to simplify radicals. So it doesn't totally matter what we're going to choose for our sides, because when we set up these ratios, we're always going to get the same thing. So let's say I use my perspective. This is going to be my theta. Doesn't really matter which one. But if that's my theta, then this one here is my opposite. Root 2 will always be the hypotenuse, and then this one is the adjacent. And so what I'm going to get is sine of 45 degrees is going to be the 1, the opposite, over the hypotenuse, 1 over root 2. And notice that if I had chosen the 4 over 4 root 2, the 4s would just cancel, right? I still get the same ratio, and that's why ratios are so useful here. It doesn't matter how big the triangle is, it just matters what its proportions are. Cos of 45 is the adjacent, which is also 1 over root 2, and tan of 45 is 1 over 1, which is 1. Sometimes you might see these things written in that sort of simplified version for the radicals. So if you remember to simplify these, what you would do is multiply by the radical in the bottom. So multiply by root 2 over root 2. And the purpose of that is so that along the bottom, when we do root 2 times itself, the squaring cancels out the root. And what we actually get is just 2 along the bottom. So root 2 over 2. Either of those are fine to me. I don't really care. But if you're checking up things in like a textbook or anything, you'll usually see it in that rational on the bottom. So you want the 2 on the bottom notation. All right, so that is the pi over 4. The pi over 3 and the pi over 6. So the reason why I put those two together is because they're going to both go in the triangle together. So pi over 3 is 180 degrees over 3, which is 60 degrees. And pi over 6 is 180 degrees over 6, which is 30 degrees. So these are actually the two angles that go together in a right angle triangle. That one looks a little bit better. So this would be, let's say, 60, and this might be 30 degrees. And so yeah, so this would be our 30, 60, 90 triangle. And how we're going to get this one is I'm actually going to sort of double up this triangle. So I'm just going to do the exact same triangle on the right-hand side there. So this will be 60, and then this will be 30. But then what you'll notice is that whole angle across the top is actually 60 degrees now. And now what we have is an equilateral triangle. So all three sides are the exact same, which should mean that I should be able to have 2, 2, and 2 all the way across. But then for my triangle here on the left, if that bottom is 2 all the way across, then that left half should just be 1. And then we could use the Pythagorean theorem. If I call this, let's say, x here, that height, then what I should have is that x squared plus 1 squared equals 2 squared. So x squared plus 1 equals 4, x squared equals 3. And so that's actually going to give us root 3 for that height. And then we should be able to get all of our trig ratios from there. So I will have, let's say, sine of 30 degrees. It's going to be my opposite 1 over hypotenuse 2. Cos of 30 degrees is the adjacent, which is root 3 over the hypotenuse 2. And tan of 30 degrees is the opposite 1 over the adjacent root 3, which again, you might typically see that written as root 3 over 3. So either of those will be fine. And then if we do the other ones, sine of 60 is going to be now the opposite for the 60 is the root 3. The hypotenuse doesn't change. Cos of 60, so now the adjacent is the 1. And tan of 60 is actually just going to be the flip of the tan of 30. So tan of 60 would be root 3 over 1. And so those are all of our special ratios. We can write them in fairly nice ways. We do need some radicals, but these are things that you're probably going to want to be familiar with. For this course, you don't have to have these things memorized, but depending on which courses you take in the future, you might need to know these. I never memorize them. I draw these pictures and I get my numbers from the pictures because I don't like memorizing things. So yeah, if you can kind of put together how I made these triangles, you should be okay to come up with these numbers on your own.